Hi Year 7s, welcome to your third lesson in the forces topic. My name is Mrs. McGee, I'm one of the science directors, and today we are going to be learning about stretching materials. So before we start this lesson, you will need a pen and paper, a ruler, and some graph paper. Now if you're in school, you should be able to get all of those. If you're at home and you have some graph paper, brilliant. If you don't though, don't worry, I will show you later what you can use instead of graph paper, so don't worry too much about that. And if you are doing this lesson at home, remember that it's a good idea to try and avoid distractions. So put your phones away, or if you're using your phone to watch this lesson, then at least turn the notifications off. So we're going to get going with our starter. So what I'd like you to do is answer these three questions. Now the first two are actually recall questions from the energy topic that you did maybe a month or two ago. And then the third one is looking at the difference between mass and weight, which you should have done in your last lesson. I'm going to give you 1 minute to answer these three questions. Off you go. Okay, let's see how you got on. If you've got a different coloured pen, then grab it now so that you can mark your work. So the first question, what energy is stored in a moving object? The answer is kinetic energy. So well done if you remembered that from your energy topic at the start of year 7. Question number 2, what energy is stored in a stretched object? That is elastic potential energy. So again, well done if you remembered that. And question 3, what is the difference between mass and weight? Now you did this last lesson, so mass is how much matter there is in an object, and we measure it in kilograms, whereas weight is the force that pulls an object down due to gravity, and that is measured in newtons. So remember, mass is kilograms, weight is a force measured in newtons. So in today's lesson then, the first thing that we are going to do is look at how we can describe an investigation into the stretchiness of different materials. So that's what we're focusing on today, is how can we investigate different stretchy materials. And then in the second part of the lesson, after we've looked at an investigation, we're going to analyze the results from this investigation. So I just want to start by reminding you of one of the key things that you learned in the last lesson, which was this relationship between weight, mass, and gravitational field strength. And you practiced using this equation, weight equals mass times gravitational field strength, or just weight equals W equals mass times G. Now on Earth, which is where all of our investigations are based, obviously, in science when we're in school, the gravitational field strength is 10 newtons per kilogram. Now you might occasionally see in some textbooks or in some questions it says 9.8 newtons per kilogram, but for today's lesson we're just going to round that up to 10. So G on Earth is 10 newtons per kilogram. So when we're on Earth, we have our mass. So for example, my mass is 65 kilograms. Okay, so the mass is how much of me there is. So there is 65 kilograms of me. And that wouldn't change whether I was on Earth or on a different planet or on the moon. But I want to work out now what is my weight. So remember, weight is the force that is pulling me down towards the center of the Earth, because it's the force due to the Earth's gravitational field strength. So if I want to work out my weight, I'm going to have to use the equation weight equals mass times gravitational field strength. So it will be 65, which is my mass, times 10, which is what I've said we're using for G on Earth today. So 65 times 10 is just 650. So my weight on Earth is 650 newtons. I'd like you to just grab your pen and paper now and have a go at this with a couple of other numbers. So can you work out for me what the weight would be if mass is 36 kilograms? I'll give you half a minute to do that. Just use the same method as what I have just used to work out my own weight. Off you go. Okay, that's 30 seconds up. So hopefully you've done this calculation. So weight equals 36 times 10, which is the mass times gravitational field strength, and you found that it was 360 newtons. So let's have one more go. What is the weight if the mass is 0.1 kilograms? 30 seconds, off you go. Okay, let's see what you did. Hopefully you have laid out your working out as I have shown you already. So if mass is 0.1 kilograms, to find the weight, we do 0.1 times 10, because that's the mass times gravitational field strength, and you should have found that the weight was 1 Newton. So when you look at these calculations, what you can see is that the greater the mass, the greater the weight pulling down on the object, or the smaller the mass, the smaller the weight pulling down on the object. Okay, so when we investigate stretchy materials, there are lots of different materials that you could look at. So you could investigate how well elastic bands stretch, a slinky or other spring, balloons or rubber gloves, or even strawberry laces. Now the strawberry laces investigation is the one that we really like to do with year 7s in school. Unfortunately, if you're watching this video, it's because you can't do the practical in school at the moment. But as soon as we are able to do these practicals again, or as soon as you're back in school, at some point we will do the strawberry laces investigation with you, because it is quite a fun one. But today we are going to be looking at a virtual simulation of a string practical. Now, before we do the practical together virtually, I would like you to think about how we might carry out this investigation. So the one I'm going to show you today is not using strawberry laces, unfortunately, but it's using a spring. So a spring is an object that we can stretch. We know that. That's what springs do when you pull them. And in this investigation, you can see that we've hooked the spring up to a surface above it, so it might be a clamp stand if you are in school. And then to the bottom of that spring, we attach a mass, and then we use a ruler to measure the length of the spring. So what we're trying to find out in this investigation is how much does the spring stretch every time we add a mass. Okay, so before we go on to the investigation, I'd like you to think of 4 things for me, please. The first is, what would our method be? So on the next slide, I'm going to show you some steps, and I want you to put these steps into the correct order to show me what the method is. Second, I'd like you to think about what you are changing in this practical. So when you do the practical, what is the factor that you change every time? And then what is the factor that you are measuring? And then the last thing I'd like you to think about is, what are the factors that you are keeping constant? What are the ones that you are keeping the same to try and make this a fair test? Okay, so we'll go through each of those 4 together, one at a time. Okay, so the first thing that I would like you to do then is read these steps here, but they are not in the correct order. So I would like you to write them out in the correct order. Okay, I'm going to give you 2 minutes to do this, but if you need more time, just pause the video to finish it off. Off you go. Okay, so let's see how you did. Now remember, if you need a bit more time, just pause the video to finish off this task before going through the answers with me. So the first step in the investigation is to attach the spring securely to the surface above it. So remember, in a lesson, this might be a clamp stand. The second thing that you would do then is you would measure the initial length of the spring. Okay, so that is the starting length of the spring before we have even added any masses to it. Step 3 then is to add a 50-gram mass to the bottom of the spring. Okay, now when you have done that, the next step, step 4, is to measure the new length of the spring. So you've added the mass, presumably the spring has stretched a little bit, so we're going to measure the new length of that spring. Step 5, you're then going to add another 50-gram mass to the bottom of the spring. So now you've added a total of 100 grams. And again, you measure the new length of that spring. And then the final step, you're going to repeat these steps again, each time adding a 50-gram mass until you get to a maximum of 300 grams. So well done if you got those steps for the method in the correct order. I'm now going to give you another 2 minutes to do questions 2, 3 and 4. So in this method, what is it that you are changing? What is it that you are measuring? And can you think of some factors that you will be keeping the same? 2 minutes, off you go. Okay, 2 minutes are up. So grab your different coloured pen and let's go through these together. So question number 2, what is it that you are changing? In this investigation, we are changing the mass that is added to the end of the spring. Okay, so the first time we do it, we've added 50 grams. The second time, we've added a total of 100 grams. The third time, it would be 150. The fourth time, it would be 200, etc., until we get to 300 grams added. Question 3, what is it that you are measuring? Each time we add an extra 50 grams of mass, we are going to measure the length of the spring, and that's what we use the ruler for in this investigation. And then question number 4, what are you keeping constant? There are lots of different things that you could have thought about. One of them might have been the material that the spring is made of, so the type of metal that it's made of, because that could affect how much it stretches. The second is the width of the spring, or how thick the spring is. Again, that could affect how much it stretches. A third one could be the starting length of the spring. So if you start with a shorter spring or a longer spring, again, that could affect how much that spring stretches. So all of these factors are ones that we want to keep the same to make this a fair test or a valid experiment. Okay. Now, there are 3 key words that you might have encountered before, but that we need to start to become familiar with when we're doing science practicals. And these are the 3 types of variables. So the variable that we're changing, we call our independent variable. So the independent variable is the one that I change in a practical. Okay, the word independent starts with the letter I. It's the one that I change. Now, the variable that we measure is known as the dependent variable. So that's the one that we are measuring to find out if it depends on the independent variable that we're changing. Okay, that's why it's called the dependent variable. And then the third type of variable is our control variables. So these are the variables that we keep the same. We control them so that they do not change because we want to make this a valid experiment. Okay, so in this practical today, we are going to be using this virtual simulation here that you can see, and we've got a spring there, and I can add different masses to this spring, and we will be able to measure how much it stretches the spring by using this ruler here. Okay, so I'm just going to place the ruler there, and you can see that you will be able to measure in millimeters. So this ruler is measuring in millimeters what the length of this spring is. So we're going to be adding masses starting at 50 grams and increasing all the way up to 300 grams. So the first thing that we need to do is actually draw our table. So I'd like you to grab a ruler if you have one. If you're at home and you haven't got a ruler, then you can always get your planner. There's one of the hard edges on your planner can be used as a ruler really well. So I've got my trusty Spider-Man ruler here that I borrowed from my daughter today at home. So let's draw this table. We're going to do 3 columns in the table. So in the first column, we are going to have our mass. And today we're going to be measuring our mass in grams. I know that normally we would measure mass in kilograms, but these masses that we're adding are so small that it's easier to measure them in grams than in kilograms. The second column is going to be our weight. Now remember that weight is a force, okay? So it's going to be measured in newtons. And then in our third column, you're going to have the length of the spring. And we are going to be measuring that in, let's do it in millimeters because that's what the ruler is reading. So mm for millimeters. Okay, so 3 columns. You do your table at the same time as me, please. And then our first mass is going to be 50 grams. In fact, no, our first mass will be 0 grams. So we are going to measure the length of the spring when there is no mass added at all. We're then going to add a 50 gram mass. Then we're going to add another 50 grams, so that's a total of 100 grams. Then 150, 200, 250, and we will go up to 300 grams. Now you'll notice that I haven't added the unit here every time. That's because in my heading I put grams in brackets. So if you do that in the heading of your table, then that's great. If you haven't written grams up here, then you do have to add grams for each of your numbers like that going down the table. Okay, so we usually suggest that you put the units in the heading of the table because that makes it much easier. So go ahead and finish your table. I'll give you another half minute to do that whilst I'm just tidying mine up. And then we'll start the practical. Okay. All right, if you need a bit more time to do your table, just pause the video. Otherwise, let's have a look at what happens then when we add different masses to this spring here. So I'm going to start off with adding, the first result that we need is when we have no mass added at all. So that's what we call the starting length or the initial length of the spring. So we can see here, if you look at the ruler, that the spring, the initial length of the spring is, I would say, 48, just about 48 millimeters there. Okay, so there's our first result. So when there's no mass added, the initial length of the spring is 48 millimeters. Okay, remember our unit is millimeters. Now we can work out our weight as well. If there's no added mass, so I could put added here, couldn't I? If there's no added mass, then the weight added to it, so again, it's what we're adding to it, is 0. Okay, so we've added no weight to it at all, so it is 0. So remember that 0 newtons for weight. Okay, so now let's add our mass. So our first mass is going to be 50 grams. And you can see that the spring has stretched, so I'm going to move my line down so we can see what the new length of the spring is, and it is 56 millimeters. So with 50 grams added, length of the spring is 56 millimeters. We'll work out the weights afterwards. Let's just keep going with collecting our data. So I'm now going to increase this mass to 100 grams. So now the mass added is 100 grams and the spring has stretched again. So let's see what the new length of the spring is. And that looks like it's pretty much bang on 65 millimeters. Now we're going to increase it to 150. So now my mass added is 150 grams. And it looks to me like the new length of the spring is 72 millimeters. Let's increase our mass to 200 grams. There we go. Stop it bouncing. The new length of the spring now is 81 millimeters. 250 grams. And the new length of the spring is 89 millimeters. And then the last one, 300 grams. Oh, we might just be able to do this. Just getting to the end of our ruler. The new length of the spring is 97 millimeters. Brilliant. So there are our results table. So we just need to complete this weight added column. So obviously when we added no mass, there was no additional weight. Now, if you remember earlier on in the lesson, you calculated that 0.1 kilograms had a weight of 1 Newton. Okay, now 0.1 kilograms is actually the same as 100 grams. So 100 grams is equivalent to a weight of 1 Newton. Okay, so if 100 grams is 1 Newton, then 50 grams will be half of that. Okay, so 50 grams will be 0.5 newtons. 100 grams will be 1 Newton. What do you think 150 grams will be? That will be 1.5 newtons. 200 grams will be, see if you can work it out before I say, 2 newtons. 250 grams will be 2.5 newtons. And then 300 grams, think about it, will be 3 newtons. Okay, so you can see that as we increase our mass, we're increasing the weight that's been added, and we have got our measurements for the spring length. Okay, so if we think back quickly to the learning outcomes of this lesson, our first outcome was to be able to describe how we investigate the stretchiness of materials. Well, you've done that when you were working on your method, and we have just collected the data together with the virtual experiment. We're now going to look at how we can analyze the results from this investigation. Okay, so we're now going to have a look at how we could present our results in graph form, because it's often easier to see the pattern in our data when we put it into a graph rather than when we're just looking at it in a table. So if you are in school, then you should be able to get your hands on some graph paper. I'm at home, so I've got this square paper that I'm going to be using rather than graph paper. So this is the kind of thing that you might find in a maths lesson. If you're at home and you haven't got any graph paper or square paper, just use some lined paper or even just some plain paper. That'll be absolutely fine. You just might have to be a little bit more careful with how you are drawing your points, plotting your points. So we're going to start by drawing the axes. So the bottom axis is what we call our x-axis. So if you've got a pencil, then that's better than doing it in pen, just because you can then rub out any mistakes if you make any. But if you haven't got a pencil, don't stress too much, just use a pen for today. So the bottom axis is my x-axis, and then I'm going to do an axis along the left, which is my y-axis. Now, in maths, you would just call them x and y axes, but in science, we have to label them with what they actually are, with what we're going to be plotting on these axes. So in science, on our bottom axis, our x-axis, we usually put our independent variable. So this is what we have changed in the experiment, okay? So remember, in this experiment, what we changed was the amount of mass that was added. So we're going to put here our mass added. And we put the unit, which is grams. So we added first 0 grams, and then 50 grams, and then 100, and then 150, and so on up to 300. So the easiest way that I'm going to do this is just, let's see if I can do, so 0 will be where my origin is here. So 50, 100, 150, 200, 250, 300, that fits really well on my scale here. So let's write the numbers. So 50, 100, 150, 200, 250, and 300. So those are grams of mass added. Okay. If you need to pause the video now to do your x-axis, do. If you're ready, we're going to look at our y-axis now. Now, when we label our y-axis, we're going to label that with our dependent variable. So that's what we measured in this experiment. And if you look at your data table, the dependent variable, the one that we measured every time we changed the mass, was the length of the spring. So I'm going to write here, length of spring, and the unit was millimeters, so mm. Okay, now the maximum length that we measured was 97 millimeters, so that's nearly 100. So if I divide up the space that I've got so that I can get to 100, then that should work quite well. And one easy way of doing it here would be for me to go up in tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. There we go. So that fits really nicely there. So I'll put in my numbers, and you notice that I'm going up in equal intervals. Okay, so I've gone up in tens. It may be that on your paper you want to go up in fives, or maybe you want to go up in 20s. As long as you're always going up in the same amount, by the same amounts, that's absolutely fine, okay? So these intervals here need to be equal. So going up in tens is a nice, easy option today. Okay, so there we have my graph ready to plot the points. I'm going to do the first couple with you, and then I'm going to give you 2 minutes to do the rest of them by yourself. So if you haven't quite finished your axes, just pause the video and then start it again when you are ready to. But if we're continuing now, I'm going to assume that everyone's ready. So my first data point was 0 mass added, and the length of the spring was 48 millimeters. So that's because that's the original length of the spring, the starting length. So if I go up here, my y-axis, to find 48. Now, I know that I'm not using proper graph paper, so it's going to be a bit tricky. So I'm just going to have to estimate it today. So like I said, if you haven't got proper graph paper, just do your best here. If you have got proper graph paper, then try and do this really accurately. So that's 48 centimeters there for me today. Okay, and I put it on the axis there, on the y-axis, because it was 0 grams added. Okay, now my second data point was when I added 50 grams. So when I added 50 grams, the length of the spring was 56. So again, halfway between 50 and 60 is approximately there. So it's 55, and then 56 would be there. Now, because I've got square paper here, each square is exactly 1 centimeter. So I could use my ruler to actually find quite accurately where 56 is. So I wasn't far off there actually when I was estimating. So 56 is there. Now, that's 56 millimeters for my length, but I had 56 millimeters when I added 50 grams. So it's like plotting coordinates in maths. So you have to find where those two coordinates meet here. Okay, so that's my point plotted for 50 grams added and a length of 56 millimeters. Okay, I'm going to do one more to show you. So when I added 100 grams here, the length of the spring was 65 millimeters. So I can find halfway between 60 and 70 there. So that's 65, but that was over here. So I added there. So if drawing these lines across is helpful to you, that's fine. Just make sure that you do them really light, really faint. We don't really like to see them in science. So you can do them in pencil and then rub them out, or just do them really faintly like I have done there. Okay, so there's my third point. So that's 100 grams added, and my length was 65 millimeters. Okay, so there are 4 more points for you to plot. I'm going to give you 2 minutes to do those. Off you go. Okay, so you've had your 2 minutes to plot the other points. So let's see what that should look like. So when you added 150 grams, then the length was 72 millimeters. So 72 millimeters will be here. Okay, so that's for 150 grams added. So it's going to be approximately here. Excellent. So now for my, if I added 200 grams, then my length was 81. So 81, if that's 80, then 81 is here. And that's 200 grams added, so it's just there. And then 250 grams added gave me a length of 89. So again, that's 90 there, so 89 is just below there. So 250 grams added here. There's 89 millimeters in length. And then the final one, 300 grams added, gave me a length of 97. So 97 is here. So you do it nice and carefully. 300 grams added, be that line. So it was there. Okay. So you should have a graph that looks similar. So we've got these 1, 2, 3, 4, 5, 6, 7 points plotted. Now the last thing that we need to do when we're drawing a graph is draw a line of best fit. Now in science, there are two types of lines of best fit that we can have. We can either have a dead straight line, or we can have a curve. Okay, so I know that in maths you tend to just have straight lines of best fit, don't you? But in science, you could either have a straight line, so it could be a straight line going up, or it could be a straight line going down, or we could have a curve. Okay, so there are lots of different types of curves that we could have, for example, like that, or you could have a curve going down like that, or sometimes we might even have a bit of an arc like that. Okay, so you need to decide what type of line of best fit you have. Remember, it doesn't have to be a straight line, but it can be. And the way that you decide that is by looking at the pattern created by your points. Now, does that look like a straight line, or does it look like a curve? In this case, it very much to me looks like a straight line. Okay, so we are going to take our ruler, and not every point is necessarily going to be exactly on the ruler, but we are going to draw a line that is like the average of all the points that we've plotted. Okay, it goes roughly through the middle of those points. Okay, so there we go. For me, that would be a pretty good line of best fit for this practical. You have a go at doing your line of best fit now. Okay, so the final thing that we're going to do with this investigation is write a conclusion. Now, a conclusion is where you say what it is that you found out in your experiment. And what I'd like you to do is to describe and explain the pattern in your results. Okay, now you need to be clear on the difference between describe and explain. So when I say describe the pattern of your results, what I'd like you to do is say what pattern you can see in your graph. Okay, so look at your variables, which one increases, and when that one increases, what happens to the other one? Does it increase or decrease? So you're just saying what you see on the graph. Now to explain, you have to say why you think this has happened. Okay, and when you explain, a good way to make sure that you have actually explained is to use the connective because. So this has happened because, etc. Okay, so I'm going to give you 2 minutes to do this. I'd like you to write a brief description of what you see in your graph and then try and explain why this happens. 2 minutes, off you go. All right, how did you get on? Let's grab a different colored pen and I'm going to show you one example of what you could have written, and I'd like you to compare what you actually wrote to what I say. So to describe the pattern of my results, I could say that as the mass added to the spring increased, the length of the spring increased. Okay, so as I added more mass to the spring, the length of the spring increased. All right, you might have said that the spring got longer. That's fine to use as well. So to explain this pattern, you could say something like, this is because more mass has more weight, so it is pulling down on the spring more and stretching it more. Okay, so if you relate the fact that when you add more mass, there's more weight. Remember, weight is a force. Therefore, it's going to be pulling down on the spring more, which is going to be stretching it more. That's brilliant. So we are going to finish today's lesson then with this quick matchup. So this is just reminding us of those variables, those keywords that we talked about earlier on in the lesson. I'd like you to try and remember what an independent variable was, a dependent variable, and a control variable. So I'd like you to match up the type of variable to its meaning, and then I'd like you to match it up to what those variables were in this spring practical that we did today. Okay, I'm going to give you another 2 minutes to do this. Off you go. Okay, so final self-assessment of this lesson then. Get your different coloured pen. So the independent variable is the factor that you change. So this is what you are testing. Remember, I am an independent person. I change the independent variable. And in today's practical, the independent variable was the mass added to the spring. The dependent variable then is the factor that you measure in the experiment. These are your results. And in today's practical, the dependent variable was the length of the spring. So that's what we measured every time we added more mass. And then finally, the control variables are the factors that you keep the same to make it a valid experiment. And today, one of the control variables was the width of the spring. Remember, there are other possible control variables as well, such as the type of metal the spring's made of, the starting length of the spring, or the thickness of the spring itself. So well done for getting through this lesson today. Just a reminder then, we started off by describing how we could investigate the stretchiness of materials such as a spring, and we looked at the practical, and then you have analysed those results to be able to describe actually what effect adding masses had on the spring. Now, this slide just has a summary of some of the key points from today's lesson. If you would like to add these notes to your work to make sure that you've really got the key points down, that's absolutely fine. I will leave this to run so that you can do that. Well done, and see you again in your next lesson.